Hi, this is Diya Sardev and this is the video submission for question 6 of MAT104 End-sem examination, and the question we have with us is the equation we have with us is y double dash plus 16y is equal to 4 direct delta function t minus 3y, and the condition y0 is equal to 0 and y dash 0 is equal to 0. Okay, what is direct delta function? Direct delta function can be basically defined. Direct delta function can be defined in the form of direct delta t minus alpha, means its value is 0 for t not equal to alpha, and its value is infinity for t is equal to alpha. How can we graph it is so if this is t and this is alpha, the value of direct delta function will remain 0 until alpha comes. It suddenly shoots up until infinity. It should be like more narrow, but shoots up until infinity, and then it again becomes 0. A practical example would be of for example, if we take this equation in ODE, which is a spring mass system, whatever. So one of the examples could be that if we have a spring and there's a box, if it is stretched and released suddenly, then it will produce impulse. It will produce impulse. Impulse is nothing but force for a really short time. Something which can be defined as this: force is 0, but at a particular instant it is suddenly given a lot of force, and then it again becomes 0. So a practical example of direct delta function for me can be impulse. Okay, how can we graph it? B part, this is the A part. Okay, how can we graph it? Again, if we take a mass spring function basically means that the graph will be of periodic motion, right? And direct delta function, it is given that for direct delta function it is given that it is t minus 3, that is value of alpha is 3 pi. So until 3 pi or after 3 pi, until 3 pi it doesn't move, its value is 0. So until 3 pi its value is 0, and periodic motion we can just like define it, we can just represent it by sine function or cos function. I have taken sine function here. So this is t, this is the value, this is the approximately graph according to me. Something like this will happen. How can we solve this? So the equation we have with us is y double dash plus 16y is equal to 4 direct delta to t minus 3 pi. So if we take Laplace on both sides, first, so Laplace of y dash is equal to s square Laplace of y minus s y dash 0 minus y0. Now it is given that y dash and y0 is 0, so it makes, so Laplace of y dash in our case is only Laplace of y. Also, Laplace of direct delta function is equal to e to the power minus alpha s. So if you put these two equations over here, Laplace of y double dash plus 16y is equal to 4 Laplace of direct delta function t minus 3 pi. Laplace of y dash will be s square Laplace of y plus 16 Laplace of y is equal to 4. Direct derivative function is e to the power minus 3 pi s. From here we take Laplace of y common. So Laplace of y common into s square plus 16 is equal to 4 e to the power minus 3 pi s. So Laplace of y is equal to 4 by s square plus 16 into e to the power minus 3 pi s. Now using second shifting theorem, which states that Laplace inverse of e to the power minus as into fs is equal to f t minus a into u t minus a. Now in order to get y, we'll take Laplace inverse from both sides. So Laplace inverse of Laplace y will be just y is equal to Laplace inverse of s square plus 16 sine omega t, Laplace of sine omega t is equal to omega by t square plus omega square. So in this case, if we have 4 instead of omega, Laplace of sine 4t will be 4 by t square plus 16. So we'll take this. So Laplace inverse of 4 square plus s square plus 16 will be sine 4s. So y is equal to So y is equal to, so f will be sine 4t and minus a will be this part, so minus 3 pi. Y is equal to sine 4t minus 3 pi into u t minus 3 pi. This can be further written as minus sine 4 into 3 will be 12 pi minus 4t into u t minus 3 pi minus sine 40 minus 40. 12 pi minus 12 pi will be minus becomes positive, so sine 40 into u 2 minus 3 pi. This is our final equation. Now how to graph it? Since it is t minus 3 pi, there will be nothing until 3 pi. The value will be 0. After 3 pi, since it is 40 and periodic motion, the time period of a sine function is 2 pi, right, for t. So for 40 it will be 2 pi by 4, which is pi by 2. That implies that one cycle will be done until 3 pi plus n pi by 2. So this will be 3 pi plus pi by 2. This will be 3 pi plus 2 pi by 2, which is pi, 4 pi, and it goes on. This will be the time period of the function, and this will be the final graph, which is actually very similar to this graph.